Now let's have a look at estimation of the logit model. Once again, I'm going to write what the logit model is. It looks like this: Li is equal to beta 1 plus beta 2 xi, and since it's an econometric model, we'll have the disturbance term plus ui attached with it, where Li is actually your log of pi by 1 minus pi. Okay, now when it comes to estimating a logit model, we distinguish between two types of data. One is individual data at individual level, it is also called the micro level. And the second, the more important to us, is grouped or replicated data. Okay, so those are the two types of data that we have. If we have micro level data, that is, we have data on individual families, continuing with the home ownership example, if you have data of whether the family owns the house and not, and their incomes, your Li for an individual would be, if the person owns the house, 1 by 0, and if the person doesn't own the house, your Li will be log 0 by 1. So both these expressions are quite meaningless, and you cannot run the regular OLS routine, the standard OLS routine, if you have this type of individual level, micro level data. So in order to run the in these cases, remember, you will have to use the ML, or the maximum likelihood method, to estimate the parameters. So if you want to estimate the logit model rather than individual level data, what we need is the second type of data, which is called the grouped or replicated data. So in the grouped or replicated data, we will have a large number of families belonging to the same income level or group. So in the case of grouped data, we will have a large number of families belonging to the income level xi. So if we have a total of capital Ni number of families who have income level xi, and among them Ni, or the small letter Ni, represents the number of homeowners. So you will always have Ni being less than or equal to capital Ni. So if you have this data, which is group data, because for the same income level you have a large number of families at the same income level, you can actually calculate Pi as the probability of owning the house, the sample estimate of Pi as small ni divided by capital Ni. And based on this probability value, you can have an estimate of Li, which will be log of Pi hat by 1 minus Pi hat, which you can equate it to beta 1 hat plus beta 2 hat xi. Okay, and we are saying that this Li hat will be a good estimate of the true population logit Li. And the larger the size of the sample and more the number of observations capital Ni at each xi, the better and closer will be the Li hat to the true population logit Li. Now for this grouped and replicated data, after calculating the sample probabilities Pi for each income levels, you can estimate the sample Li hats for each income level. Then can you run the regular The question is, now can you run the regular OLS, standard OLS procedure to estimate the parameters beta 1 hat and beta 2 hat? Well, not quite. This is because not all of our standard OLS assumptions are satisfied. In particular, our error term UI will follow a binomial distribution rather than a normal in particular, we can say that if capital Ni is fairly large and if each observation for a given income class Xi is independently distributed as a binomial variable, then we can show that the disturbance term Ui will follow a normal distribution with mean 0 and variance 1 by Ni times Pi into 1 minus Pi. Okay, so while the mean value of the disturbance term is equal to 0, that assumption is satisfied. The homoscedasticity assumption is not satisfied. It is being violated because the variance sigma square depends on Pi, which again depends on or will vary with the value of Xi. So remember, you will have to use the weighted least squares method, which is suggested when you have the problem of heteroscedasticity. Now empirically, when it comes to estimation, the population Pi is not known, and therefore the population sigma square will also be not known. So instead you can use its unbiased estimator sigma hat square, which can be written as 1 by Ni Pi hat into 1 minus Pi hat. Okay, this is the estimator of the population variance term sigma square. So let's have a look at what are the steps involved in estimating the logit regression. First, for every income level Xi, calculate Pi hat, which will be given as Ni small ni divided by capital Ni. So capital Ni is the total number of families at income level Xi, and small ni is the number of families at this income level who own the house. Right? Now, based on these PIs, you can obtain or calculate Li hat, which is given by the formula natural log of Pi divided by 1 minus Pi hat. We know that this model suffers from heteroscedasticity, so obtain the weighted least squares equation, weighted least squares method, where the weight to be applied, Wi, will be Ni times pi hat times 1 minus pi hat. So using these weight, you can transform your model into one which satisfies all the assumptions of the OLS. And then you can apply the OLS technique to find the WLS or weighted least squares estimators. And these estimators will be blue. Okay. Finally, you can use these estimators for your building your confidence intervals or testing the hypothesis, as we have been doing for the models that we have discussed earlier. One thing that you have to remember is that all these conclusions of the logit model are, strictly speaking, valid only when the sample size is reasonably large. Okay, so that is how the entire logit estimation is carried out. In the Gujarati book that you have with you, you can actually go through a numerical example that is given, which is very useful in explaining how to interpret the results of the grouped logit model. Remember, it's called a grouped logit model because we are working with grouped or replicated data. So some books also call it the G-logit logit, where G stands for grouped logit. So I'll end this section by just reminding you that if you have individual or ungrouped data, you cannot use the standard OLS or even the weighted least squares method. You will have to choose non-linear estimating procedures. In particular, the maximum likelihood or the ML method is good at solving these kind of or estimating these kind of regressions. But remember, the ML method is also more suitable for large sample sizes. That's it about logit. We will now proceed on to the probit model in the next lecture.